All right, so 11-3 is the last section that we're going to review out of Algebra 1-2. And then we're going to go to new material and take all of that foundation of radicals and extend it to new information. So 11-3 is radical equations. And example 1. So you are to solve. So we'll start out with something fairly simple. So this is question A. The square root of negative k is equal to 4. Remember, we're finding the principal square root. So unless there's a negative out in front, we're assuming we're finding a positive square root. We can't take the square root of a negative. So what does k have to be so that this is not a negative under here? Nope, not no solution. Because this is actually read the square root of the opposite of k is 4. So for this value underneath here to be positive, what does k have to be? What kind of a number? A negative number. So watch what happens. How do we solve radical equations? Yep, get the radical by itself on one side, which it is, and then square both sides. This process of squaring both sides doesn't always give us a valid answer, so we do have to check our answers. So when I square that radical, I get exactly what's underneath the radical. So in this case, negative k. 4 squared is 16. And so what would k equal? Negative 16, right? So multiply or divide by negative. So you have to check that answer, every answer. If you don't check that answer, I mean, it's possible that this is no solution, and you won't know it if you don't check it. So go back. The opposite of negative 16 is a positive 16. Square root of that is 4, so the answer is good. So my check, if I made you write out the check, would look like this. I would take my original problem, and instead of the variable, I would have substitution parentheses. I'm going to plug in that negative 16. So you can see that the two negatives make a positive 16, and then the square root of 16 is 4. So 4 does equal 4. So the next one is the square root of x plus 3 is equal to negative 5. You solve that one on your own. Make sure you check your solution. So solve that on your own and check your solution. Bless you. So share your answer with those around you. See what they think. Compare to somebody. Because you might be wrong, or you might be right, and they're wrong. What solution did you get? 22? Does that work? You do get 22 as an answer, but does it work? No. And you could have just stopped right here and said there's no solution. Why? From the very beginning, you could have done no work and said there's no solution. Why? Yeah, when you take the square root of something, you're not going to get a negative number. It's not possible. So that's why the 22 doesn't work in here, and my answer has to be no solution. If you are going to show no work and just say no solution, I want to hear you say it's no solution because you cannot get a negative answer. So do justify your answer slightly if you're not going to show work. So there's a perfect example why we're checking. So example 2. You are to solve Question A, square root of x minus 3 plus 8 is equal to 15. Can I square both sides as it is? Nope. What do I have to remember to do? Yeah, I have to get that that radical on one side by itself, so I do have to subtract the 8 from both sides. So that gives me the square root of x minus 3 is equal to 7. When I square both sides, I get exactly what's underneath that radical, which is x minus 3 equals 49. Now add 3, x is equal to 52. But again, I want to check it. Just because I've got a positive answer over here doesn't mean that whatever I get here is going to work. So when I check, I'm going to put in 52 minus 3 plus 8 equals 15. Do not move anything from left to right when you're checking. So I'm going to subtract those. Square root of 49 plus 8 is 15. Square root of 49 is 7. Plus 8 is 15. Remember, your check is like a proof. More work is better than less. So 15 equals 15 is a good solution, so that means I can accept this as an answer. Done. I want you to try this one on your own. So B, you are solving the square root of x plus 1 plus 7 is equal to 10. Solve and check. So check with those around you. Also see what your check is. What equals what? Because everybody should have the same numbers for the check. All right, so what'd you get for a solution? 8, what's your check? 10 equals 10. Very good. All right, last set of problems. Example 3. And again, you're going to solve. So A, we have the square root of x plus 2 equals, but this time we have a variable on both sides. Your goal when you have a variable on both sides is still to get the radical on one side by itself and everything else over on the other side. We're still going to square both sides. And the left side is x plus 2. But the right side is not x squared minus 16. Remember that this is x minus 4 times x minus 4. And if you distribute or FOIL, I've got x times x is x squared. X times negative 4 is negative 4x. Then distribute your second one. Negative 4 times x is negative 4x. Negative 4 times negative 4 is positive 16. You end up with a middle term. Will my x squared disappear? Will it go away when I start collecting like terms? No. So what I would do is keep the x squared on the side where it's positive, which it's on the right side, positive. So I'm going to move the x and the plus 2, so I have everything over to the right side, and one side set equal to 0, because I'm going to have to factor this all. So I'm going to subtract an x and subtract a 2. So line it up with your like terms. And then write it in descending order. So my highest degree term is x squared. Then I have a negative 4x and a negative 4x, which is negative 8x. Plus that negative x makes it negative 9x. 16 and negative 2 is a positive 14. Are there any factors of 14 that add to give you 9? Yeah. So I want a negative 9. So I've got a 2 and a 7 add to give me 9. My 9 is negative, so the bigger of the 2 is negative. What's the 2 have to be? Better be negative also, right? They have to add to keep the sign. Can I use a shortcut? Or do I have to use group and garbage? Shortcut or group and garbage? Shortcut, because I have a 1 in front of my x squared. So my x squared becomes x and x, and then you put your minus 2 in here, and your minus 7 in here. Set each of those equal to 0, so x minus 2 equals 0, and x minus 7 equals 0. What are your values for x? 2 and 7. So now you have to check both of those. So here's my check. So my original problem, I'm going to put in the positive 2 and see if that's equal to 2 minus 4. So 2 plus 2 is 4. 2 minus 4 is negative 2. The square root of 4 is 2. Does 2 equal negative 2? No. So I end up throwing out the 2. Try 7. Bless you. So if I plug in my 7, seven plus 2 is 9, so the square root of 9 is equal to 7 minus 4 is 3. Square root of 9 is 3, bless you. 3 does equal 3, so positive 7 is my only good solution. Sometimes both of them are going to work. You're not always going to throw one of them out. And you don't always throw out a negative, although oftentimes it seems like we do. Last problem, you're going to do this one on your own. B, you've got the square root of 2 minus y. Be careful of plugging into a negative y. So make sure you use substitution parentheses when you check. Equals y. So when you get a solution, check it with those around you. Show your solution. Talk, talk, talk. How many solutions do you get? When you solve for this, how many solutions do you get before you check it? 2. How many solutions are you left with after your check? You're only left with 1. So let's see why. So your algebraic solution looks like this. You square both sides. You end up with 2 minus y equals a y squared. That's where your highest degree term is positive, so you want to leave it on the right-hand side. So you move your 2 and your y by subtracting 2 and adding your y. So that's what I did to both sides. Write it in descending order. And so you want to take 1 times negative 2, which gives you negative 2, which means you're taking the factors of 2 and subtracting them. You're looking for a middle term of 1 plus y plus 1. So there's only one set of factors for 2, 1 and 2. They do subtract to give you 1. Your 1's positive, so the 2's positive. This one has to be negative for them to combine to give you a positive 1. You can use the shortcut because of the coefficient of y squared is 1. So y squared becomes y and y, and you put your minus 1 and plus 2. Set them both equal to 0, and you get those two solutions, 1 and negative 2. But when you check, the negative 2 doesn't work because what's outside on the right? Y. And if y is negative, it's not going to check in the original problem. You do get a positive 4 underneath here, but the square root of 4 is 2, and that cannot equal a negative number. Whereas over here, I'm taking 2 minus 1 is 1. Square root of 1 is, you can't see that. Square root of 1 is 1, and 1 does equal 1. So it's imperative tonight that you check. So one of the reasons why you'll notice that I only gave you odd questions on tonight's homework is because you're having to do double the work. You're not only solving the equations, but you're going to have to go back and check them. So you only have odds, which only gives you, I don't know, about 12 or so problems to do. But we just did 6 in about 10 minutes. So, all right, more like 17.